We've got 12 different data values, and we're going to create a box plot of this. So first task is to put it in order so we can find the median, and then we'll kind of talk about Q1 and Q3 after we find the median there. So I'm going to start by putting, let's see, 1.3 is the smallest. And as I go along, I'm going to sort of cross off numbers which kind of remind me, oh yeah, I've already found that. Let's see, 3.5 would be the next biggest. Then looks like we have 4.1. Then we have, looks like 4.5. And we have 2 of those. 4.8 would be the next one. Then we get to the 5s, so 5.0, 5, 9, 5, 6, I'm sorry, 5, 6, 5, 9, looks like 2 of those. So 5, 6, 5, 9, 5, 9, 6.3 and 6.9. Okay, so I have them in order. And so obviously I can fill in the low and the high. So the low in this case is 1.3. The high is 6.9. Okay, so I'm going to find Q1, Q2, and Q3. Okay, so Q2 is the one to start with here. Let's see, there's 12 numbers, so I want the middle most. So the first 2 partner up, then the second 2 partner up, and the third 2. All right, and I keep partnering them up until I get to the middle 2. And the middle 2, 4.8 and 5.0, since there's 2 of them, then to find the median, to find Q2, I want to add them up and divide by 2. So the median in this case would be 4.8 plus 5.0 divided by 2, which in this case is 4.9. So Q2 is 4.9. Okay, so to find Q1, let me come back here. I'm going to switch colors real quick. What I'm going to do is I'm going to focus on the bottom half of the numbers. And I'm just going to do what we did earlier. I'm going to partner them up and look for the middlemost value. So that one and that one are partnered. Those 2 are partnered. And that brings me to 4.5 and 4.1. So Q1 would be 4.1 plus 4.5 divided by 2, which is 4.3. And then I'm going to do the same thing with the upper part. So I'll just start partnering them up until I get the middle 2, and luckily it's really obvious, 5.9. Okay, and then from here I can go ahead and sketch or draw out the numbers and label the box plot. So come here, let's see. So we have 1 point, just realized that it should be 1.3 for the low. Don't know where that, my decimal point got excited there. All right, so 1.3 for the low. And then, let's see, it usually helps if we put some sort of scale on this. That way we can see if there's symmetry or stuff like that on it. So 1.3 is a little bit above. Let's see, Q1 is 4.3, so right there's that. Q2 is 4.9, and then 5.9 for Q3. So there's our box. And the max is 6.9. Okay, so even looking at our graph, we can already see a little bit of skewness to it. We've got more data on the left side than the, I'm sorry, more data on the right than on the left. The tail is where the smaller amount of data is. So this would definitely be a left skewed graph. Okay, so we can do that again. And this time we can actually do a comparison graph. So we've got two different treatments for cancer, and I would like to see is there a significant difference in, let's see, evidence suggests that high indoor radon concentration might be linked to the development of childhood cancers. The data that follows is the radon concentration of two different samples of houses. The first sample consists of houses in which a child was diagnosed. Houses in the second sample have no recorded cases of childhood cancer. So I'm just comparing houses and see if it makes a difference. All right, so first thing is to put it in order. So it looks like 5 is the smallest. Then we have 9, and then 10. And then 11, it looks like 13. Oh, 2 13s. And then 15. 21, 23, and 27, and then 39. Okay, and then I'm just going to partner those up so I can find the median. And I'm just partnering them up until I get the middle. Okay, so that guy is the Q2. And then do the same trick for the bottom half. All right, so that's Q1. And that's Q3. So our graph, so it looks like we want to go all the way up to, okay, so I'm just keeping this in my head. I want about 40s. All right, so 10, 20, 30, and 40. Okay, so it looks like our min is the 5 and our max is the 39. So about where 5 is, there's Q1, Q3, 2, and Q3. So there's that box all the way up to 39. So it looks like there's a right skewness to that set of data. And then same thing, let's put this in order. Looks like 5, 6, 7, 8, 9. Then I'm going to look 11 and 2 12s. 11, 12, 12. Then 24, 29, 29, and 38. Okay, so there's our min, and there's our max. Let's see, I'm going to start partnering these up so I can find the median. All right, so those two, let's see, 11 plus 12 over 2 is 11.5, so that's our median. It's 11.5, that's our Q2. Then I want to group the bottom half together. Let's see, 5, 9, 5, 11, sorry, 6, 9, 7, and 8. So 7 plus 8 divided by 2 is 7.5. That's our Q1. And then in the top, partner them up. Let's say 24 plus 29 divided by 2 And let's see, 40, 53, so 26.5. Q3. All right, just want to double check that. Yeah, okay. So, 10, 20, 30, and 40. All right, so min of 5, Q1 of 7.5, so really close there. 11.5, and then 26.3, so all the way over there. And 38. Okay, so both sets of data are right skewed, and it looks like the no cancer has a larger, its Q1 to Q3 is bigger, so a good 50% chunk of the data within a larger range than the cancer.